Hi everybody, in this video we're going to have an introduction to limits. We're going to define limits and learn limit notation. So we're going to start with the formal definition of a limit. The definition of a limit is, given a function f, the limit of f as x approaches a is a real number b if f of x can be made arbitrarily close to b by taking x sufficiently close to a but not equal to a. So I know that might be a lot to read and understand, so I'm going to give you a question to ask yourself to help you understand limits better. All right, and this is the question. As the x values get closer and closer to a, what do the y values of f of x get closer and closer to? So I'm going to show you an example in Desmos. We're going to look at a function f of x and find the limit as x approaches 2. Our function f of x is graphed right here to the right. We can see that the point f of 2 is undefined because we have an open circle here or a hole. But that's okay because it doesn't matter what's happening at 2. We just want to know, as I get closer and closer to x equals 2, what do my y values get closer and closer to? So we're going to start by approaching from the left side. From this side, getting closer and closer to x equals 2. And I evaluated a couple of x values here so you can see the change in y values in case you can't see graphically, right? But f of 1 is 2, f of 1.5 is 3, f of 1.9 is 3.8, f of 1.999 is 3.998, and 1.99999 is 3.9999999. So you can see that as my x values are getting closer and closer to x equals 2, my y values are getting closer and closer to y equals 4. So that means the left-hand limit is going to be equal to 4. As we're approaching from the left-hand side, our y values are approaching 4. Let's look at the right. If I were to approach from the right side, coming from this direction and getting closer to x equals 2, I plugged in a couple values so you could see numerically what's going on here. F of 3 is 6, f of 2.5 is 5, f of 2.1 is 4.2, f of 2.001 is 4.002, and f of 2.000000001 is 4.000000002. So as we're getting closer and closer to 2 from the right side, we can see that our y values are also getting closer and closer to 4. So what is the conclusion we can make? It's that the limit of f of x as x approaches 2 is 4. So there's your example of what a limit is. Remember, the question that you're always going to ask yourself is, as x gets closer and closer to 2, what does y get closer and closer to? So now let's look at some limit notation. How do we write this out mathematically? So we write the limit as LIM as x approaches a. So underneath your LIM, you're going to put x arrow a for x approaches a. Of f of x, so there you put your function. If it was g of x, you put a g of x right here, is b, so equals b. That's our limit notation. That's how we write this idea mathematically, and we can read this as the limit as x approaches a of f of x is b. We could also read this as the limit of f of x as x approaches a is b. Part 3, let's get into practicing limits and limit notation. So as x values approach x equals 1, what are the f of x values approaching? Remember, this is the question that you're going to ask yourself whenever you're looking for a limit. So the x values I'm approaching are x equals 1. So I'm going to take a look at where x equals 1 is on my graph. Here it is. And I'm going to look from the left side and the right side. So from the left, if I'm starting here and getting closer and closer to 1, it looks like the y value I'm approaching is 2. And from the right, the same thing. As I'm getting closer and closer to 1, the y value I'm approaching is 2. Now you may say, wait a minute, f of 1 is actually equal to 3 because we have this point up here at 3. And that's true, but it's important to remember that the limit is not about what the actual value at that point is. It's about what are you approaching as you're getting closer to that point. So as we get closer to 1, what y value are we approaching? 2. So as x values get closer and closer to x equals 1, the f of x values get closer and closer to y equals 2. Now we're going to translate that sentence into limit notation. As x values get closer and closer to 1, f of x values get closer and closer to 2. So how do we write this in limit notation? Remember, we're going to start with the limit, LIM. As x approaches, and what x are we approaching here? 1. Of your function, so our function here is f of x, is, and then the y value that you're approaching, which is 2. So that's how you translate this sentence into limit notation. All right, I hope this video helped. Thank you for tuning in and happy studying.